for the answer in 1AI because it is a good heat conductor. B1, the thermometer is then brought outdoor, which is very much hotter than in the house. Complete the following sentence by ticking the correct answer. The outdoor temperature is taken when the thermometer. The answer is starts to expand.
Starts ke stop?
Starts.
Okay, untuk 1A2 ada banyak jawapan So salah satunya dari kawan awak cakap tu, ada lagi jawapan lain? So other answer is it expands and contract uniformly. So that is one reason kenapa kita guna 1A1 tu. 1A1 tu tadi apa? Alkohol kan? Mercury ataupun alkohol. Okay. And then B1, the thermometer then brought outdoor, which is very much hotter than in the house. Complete the following sentence. The outdoor temperature is taken when the liquid in the thermometer start to expand ke stop expanding, class?
Stop.
So this one we relate to topic subtopic yang mana satu. So this is about thermal equilibrium. Okay, so the answer must be stops expanding. Agree? Yang lain agree tak?
Agree.
Yes.
Right,
Agree.
kenapa stop expanding? Sebab because this is dia kan masa dia expand tu dia akan terus expand, tapi temperature yang sebenar ialah when it stop expanding, which is thermal equilibrium is reached at that moment. Okay, and temperature is the same. Alright, okay, continue.
B2, name the physics principle involved in 1BI. Thermal expansion of substances, but the correct answer is thermal equilibrium.
Yes, thermal equilibrium. Thermal expansion of substances ni ada ke prinsip? Ni topik apa ni? Tak ada kan? Jadi this one tak tepat lah jadi kita kena relate balik dengan topik pertama dalam heat ni, thermal equilibrium. Okay, applications of thermal equilibrium. Salah satunya ialah thermometer. Okay, ada lagi? Dah kan?
Ada lagi cikgu.
Okay, sikit.
Okay, next question. Diagram below shows a mercury thermometer which has not been calibrated. First question, state the physical change in the mercury when the temperature increases. The volume of mercury increases when the temperature increases.
Okay.
Why is mercury used in the thermometer? Because it is opaque, so it can be seen easily.
Alright, ada jawapan lain tak selain daripada opaque?
Boleh, kalau does not stick to the glass wall of the thermometer.
Boleh. Okay, tadi pun dah sebut dua kan? Soalan yang lebih kurang sama dengan yang tadi. Good heat conductor, uniform expansion. Okay, continue.
Okay. The length of the mercury column in the thermometer is 2.6 cm at 0 degree Celsius and 22.6 cm at 100 degree Celsius. So untuk lagi senang kita classifykan at 0 degree Celsius tu as L0, to 22.6 cm tu as L100. So what is the difference in the length of the mercury columns at 0 degree Celsius and at 100 degree Celsius? So dia nak difference between L100 dengan L0. 22.6 minus 2.6 will get 20 cm.
Okay.
Alright, when the thermometer is placed in hot oil, the length of the mercury column is 16.9 cm. Calculate the temperature of the hot oil. To answer this question, we need to know the equation, the formula. Theta is equals to L theta over L100 times 100 degrees. Tapi dekat soalan ni kita ada L0, jadi both L theta dengan L100 kena tolakkan dengan L0. So to find the theta, 16.9 minus 2.6 over 20. 20 tu kita dapat. 20 tu kita dapat masa 22.6 tolak 2.6. Darab dengan 100 degree Celsius, we'll get 71.5 degree Celsius.
Next question. An experiment is carried out to investigate the relationship between the pressure P and the temperature of a fixed mass of a gas. The graph of a pressure P against temperature obtained is as shown in diagram below. First question. What is the value of temperature when the pressure of the gas is zero? Jawapan dia negative 273 because the gas molecules no longer move and do not collide with the walls of the container. Hence, the gas pressure becomes zero.
Okay.
Next question, what is the name given to...
Okay. Untuk soalan 2A1, let's see, soalan tu saya tambah. What is the value of temperature in Kelvin when the pressure of the gas is zero? Kalau in Kelvin, what is the answer?
Zero.
0 Kelvin. Okay, good. Thank you. Continue.
Second question, what is the name given to TO? The answer is absolute zero. C, in the space below, sketch the graph of pressure P against temperature when the temperature of a gas is expressed in Kelvin. Gas pressure is directly proportional to absolute zero.
Okay.
Tu je.
Alright. So, from your friend's answer, okay, thank you group ni, daripada jawapan-jawapan tu nampaklah dah faham banyak lah kan. Jap, is it Gay-Lussac's law? Alamak, dah tutup pula. Sorry, 2B. So 2B tadi, what was the question? Okay kelas, cuma tengok sama-sama. So buka sendiri you all punya tu. So 2B, name the physics law that explain the observation of the above experiment. Is it Gay-Lussac's law? Kenapa Gay-Lussac's law? Gay-Lussac's law is about apa?
Pressure and temperature.
Pressure and temperature. Okay. Right. So make sure bila macam soalan-soalan macam ni, name the law, name the principle, make sure you write down the name correctly. Okay. Yang ni double A ke? Betul kan?
Betul cikgu.
Betul.
Okay. Thank you very much. Okay. Nampak. Right. So next group. Okay. Thank you. This group bagus. Jawapan-jawapan ada satu je yang tak betul tadi. Yang awal-awal tadi. Okay. Kita continue dengan the other group.
Nampak kan?
Nampak?
Okay. Untuk Assalamualaikum warahmatullahi wabarakatuh. Kumpulan kami akan membentangkan daripada muka surat 10 hingga 13. Number 1, diagram 1 shows the change of phase when 100 gram of steam is changed to ice cube. Then Q1, Q2 and Q3 are the heat energy released during the cooling process. Name the heat energy Q1 which is released from Q to R, which is from steam to water. Jawapan kami ialah latent heat of vaporization.
Okay.
Next, take the correct answer to describe the change of an average kinetic energy during the change of phase from Q to R. Unchanged. Then give one reason why the temperature theta 1 and theta 2 are equal even though the heat energy is released. The released heat energy is not converted to kinetic energy of the molecules. Then calculate untuk C, calculate the total heat energy Q2 and Q3. which is released from R to T. Lepas tu dia ada bagi tahu specific latent heat and specific heat capacity. Cara dia, kita nampak daripada R to S, temperature berubah but dia punya substance pula. Dia punya state tak berubah. Lepas tu S to T, dia punya temperature state berubah tapi temperature tak berubah. So, total heat energy release is equals to heat release to cool the water, which is temperature berubah, plus dengan heat release to freeze the water, which is state yang berubah. Formula dia MC theta plus dengan M latent, ML besar F, tapi sini tak tulis. So 0.1 darab dengan 4200 darab dengan 100 tambah 0.1 darab dengan 3.36 darab dengan 10 power of 5 dapat 75,600 joule.
Okay, good.
And then last question on diagram 4.2, sketch the graph of temperature against times to show the change phase from Q to T. So first kali Q to R, dia punya yang berubah ialah state, R to S yang berubah ialah temperature, and S to T yang berubah ialah state. So kita orang buat graph jadi macam ni.
Okay, tengok balik gambar. Cuba scroll balik atas. Okay, from Q to R, what is the change of state?
Steam to liquid.
Okay, so kita sepatutnya you all draw horizontal line at 100 degrees Celsius. Okay, then from R to S,
Temperature berubah.
ya, graph dia ada slope kan? Negative slope daripada 100 to 0 kan? Betul tak? Temperature change dia from R to S 100 to 0 kan?
Okay.
Okay, jadi bila tengok graph, dekat mana 0?
Kat bawah sekali.
Jadi R to S tu dia kena sampai the axis. Jadi axis tu boleh improve lagi. Letakkan 0, letakkan 100. Bentuk dah betul dah, pattern dah betul. Okay, however, sebabkan ni satu markah, jadi dia kena complete semualah. Jadi 100 tu, kat mana nak letak? 100 tu sebelah Q. And then kita letak 0. 0 dekat x-axis tu. Jadi R tu ke bawah sampai bawah. Okay, boleh terus betulkan macam tu. Okay, yeah. So when you get this kind of question, look at the values. Kalau perlu labelkan value-value, labelkan. Okay, R to S tu drag sampai ke bawah. Susah sikit nak buat tengah online kot. Jadi dah. Okay, yang lain tu pun okay, good. Right, so now dah jadi betul. Okay, alright. Thank you. Adik sambung seterusnya.
Ada.
Okay, so soalan next. Diagram 1 and diagram 2 show trapped air into identical flask heated with different quantity of heat. Both stoves are turned off after 10 minutes. So ada dua diagram kat sini. Okay, turun sikit. Okay, so soalan first, state the physical quantity measured by a Bourdon gauge. So Bourdon gauge, dia measure pressure.
Okay, spesifikkan lagi. Pressure ada banyak. Pressure kita ada water pressure, gas
Pressure
pressure.
of liquids dengan gases.
Pressure of siapa?
Gas.
Is it liquid?
Gas pressure.
Air pressure, gas pressure.
Okay, so next, based on diagram 1 and diagram 2, compare the readings of both the Bourdon gauge. Okay, so untuk first ni, diagram 2 has higher reading of Bourdon gauges than diagram 1.
Okay, good.
Next, compare the readings of both thermometers. diagram 2 has higher reading of thermometer than diagram 1. Lepas tu, state the relationship between the heat supplied and the temperature. The higher the heat supplied, the higher the temperature. Number 4, state the relationship between the pressure of air in the flask and the temperature. The higher the temperature, the higher the pressure of air in the flask.
Okay.
Untuk C, based on kinetic theory, explain the reason for the answer in B4. The higher the temperature of the gas, the higher the average kinetic energy of the gas molecules. The rate of collisions of gas molecules with the walls of the container increases. So force per unit area on the wall of the container also increases. So the temperature increases.
Okay, dapat markah. The rate of collision of gas molecules, 1 markah. The rate of collision of gas molecules with the walls increases. Okay, itu 1 markah. Okay, and then force per unit order also increases, so the pressure increases. Ada tak sebut higher kinetic energy? Ada, so betul. Okay, so 2 marks kat sini. So you can, dia punya orang kata step ataupun rank dia kan. First you talk about the molecules move faster. Bila molecules move faster, kinetic energy increases. So bila kinetic energy increases, more collision between molecules and wall container. Okay, 2 marks. Okay, next.
Okay, so untuk D, name the wall involved when the air volume is constant. So the Gay-Lussac law.
Okay. Dia je betul-betul ya. Okay, continue. Ada lagi?
Ada.
Terima kasih.
Okay, thank you. So dah 2 kali lah we talk about Gay-Lussac's law. Alright, next group. Please.
To present page 14 to 17. Okay. Soalan nombor 8. Diagram below shows 2 models of frying pan. What is the meaning of specific heat capacity? Specific heat capacity is the amount of heat energy required to change the temperature of 1 kg. Mia Edina.
Besarkan sikit Mia. Boleh tak awak?
Nampak tak?
Okay. Boleh. Dah.
Okay. What is the meaning of specific heat capacity? Specific heat capacity is the amount of heat energy required to change the temperature of 1 kilogram of a substance by 1 Celsius.
Okay, 1 degree Celsius.
Okay.
Good.
Based on the information in diagram above, state the suitable characteristics of the frying pan used for cooking. Give reason for the suitability of the characteristics. Type of surface, dark surface. Reason, more effective in absorbing heat. Specific heat capacity, low specific heat capacity. Reason, can heat up faster.
Yep.
Based on the answer in B, determine which model of frying pan in diagram above will absorb the heat effectively. Give reason for your choice. Model B, because it is made up of dark surface, which is more effective in absorbing heat and has low specific heat capacity, which can heat up faster.
Okay, model B 1 markah, dark surface 1 markah, 2 markah. Okay, good.
A kettle contains 0.5 kilograms water. The average heat absorbed by the water is 16 joules as power of -1 in 25 minutes. Calculate the rise in temperature of the water. So firstly, we calculate the total energy required. Since it is 16 joules seconds power of -1, we have to remove the seconds -1 first by multiplying with 25 minutes. So we'll get 24,000 joules. Okay. Then we'll find the rising temperature of water using the formula Q equals to MC theta. Then we'll get 11.4 degrees Celsius. Both of the questions are the same, teacher.
Okay. Right.
Okay.
Ini betul jawapan.
Hmm.
Okay. Dah. Alright, so yang lain sambil tengok, sambil buat apa, sambil tanda kan? So hopefully semua orang buat lah Okay. Okay, continue.
Question 2. What is the meaning of specific heat capacity? Meaning is specific heat capacity is the amount of heat energy required to change the temperature of 1 kilogram of a substance by 1 degree Celsius.
Okay, sama tadi. Thank you.
Question B2, B1. Give reason for the suitability of the characteristic. Material for making the pot is copper. Reason because it can heat up faster. Question 2. Material for making the handle of the pot. Polymer. Reason a better heat insulator. The mass of the pot. Low mass. Reason dia ialah has lower specific heat capacity and can heat up faster.
Okay.
Question C.
Sekejap, tadi 3 tadi mana? Sorry.
Mass of the pot.
Okay.
Question
Lower
C.
mass selalunya kita sebut selain daripada tu lower mass kita boleh kata easy to handle pun boleh. Kan, portable. Okay, C1.
Okay, question C dia suruh calculate the temperature. So C1, the clay pot, kita guna formula PT equals to MC theta. So jawapan dia ialah 354 second. Number 2, the copper pot, jawapan dia ialah 110 second.
Okay, correct. Ada soalan tak orang lain? Tak ada Okay, continue.
Question D, determine the most suitable pot that is the safest to handle and can be heated in the shortest period of time. Jawapan dia copper pot.
Okay, excellent.
Okay. Dah. Assalamualaikum warahmatullahi wabarakatuh. Group Excel 1 akan present soalan nombor 9.
Okay, bagus. Dah ada dah. Okay. Next.
Okay. A1. What is the meaning of pressure? The meaning of pressure, sekejap lah. Ya Allah, Tuhan.
Tolong Daniel, tolong besarkan sikit zoom kan.
Okay.
Bersono. Okay, thank you.
Okay, what is the meaning of pressure? A1. The meaning of pressure is the force acting normally per unit area. Okay, A2. Done. Dam.
Okay, bagi A2, Observe the diagram when the pressure exerted is 1 Pascal and then 1.5 Pascal. Compare the volume of trapped air, the pressure exerted, and the temperature of the trapped air. Relate the volume of the trapped air to the pressure exerted and deduce one physics law. Name the physics law. So, for A2, the volume of trapped air when 1 Pascal is exerted, which is 3 centimeter cube, is larger than the volume of trapped air when 1.5 Pascal is exerted, which is 2 centimeter cube. The temperature in both ranges are the same, which is 28 Celsius. When pressure exerted increases, the volume of trapped air decreases. So pressure is inversely proportional to volume for a fixed mass of gas at constant temperature. The physics law used is Boyle's law.
Okay, okay, kejap. When pressure increases, volume okay, but the temperature unchanged. Alright, good. But terima markah.
For question B, diagram 3.2 shows the air bladder of a fish. Explain why the air bladder expands when the fish moves up quickly from the deep sea. So liquid pressure is directly proportional to the depth of the liquid. When the fish moves up quickly, the depth decreases because the pressure acting on the fish to also decrease. The air bladder of the fish expands when the liquid pressure decreases. This is because the pressure is inversely proportional to the volume of trapped air. This law is known as Boyle's law.
Mana ni? Tengah baca yang mana ni?
Yang ni go for B.
Okay. When the fish moves up quickly, the depth decreases. Okay, because pressure is proportional to depth. Sekejap. Ada banyak jawapan ke apa ni? Yang atas tu beza dia. This is because
Atas tu macam guideline tu. Macam guideline kita orang.
Okay. So alright. So sekarang ni when liquid pressure is directly proportional to the depth, betul. The pressure is body decreases kan? The depth decreases. So because pressure is proportional to depth. So according to Boyle's law, when the pressure decreases, volume increases. Ada sebut tak kat mana-mana? Pressure, okay, Boyle's law betul, dapat satu markah situ. Lagi, pressure is proportional to depth ada, tandakan warna merah, betul. Bukan merah lah, betul lah. Kan awak tick ke apa, okay. 1 mark. This is because pressure is inversely proportional to the volume. Tapi apa kaitan dengan depth? Okay, so bolehlah sebab depth tu adalah representing the volume kan. Okay. Yang lain faham tak? Ada nak tanya soalan tak yang ni? Orang lain buat tak?
Cikgu.
Yep.
Next group kita orang. Tapi kita orang apa dekat tally tu dia tulis page kita orang sama dengan group ni. Kita orang tak perasan yang sepatutnya kita orang kena buat page lain ke. So lepas ni group kita orang present soalan ni sama dengan yang tengah present ni.
Soalan yang tengah di present ni?
Dekat tally tu group dia cikgu tak tahu cikgu salah tulis apa. Group kita orang sama page dengan group ni. So kita orang baru Kita orang baru perasan sepatutnya page lain. Tapi sebab kat tally tu salah, so kita nak ikut yang tally. Tapi jawapan kita orang dia lain sikit lah daripada group ni. Ada yang lain.
Okay. So jawapan you all macam mana?
Apa yang ikan ni? Sekejap.
Cuba tunjuk je jawapan. Cik Daniel, stop. Tak sebelah-sebelah tak boleh pula kan?
Cikgu, ni jawapan kita orang yang pasal ikan ni. B, Mac B.
Yang B, Mac.
The swim ladder like an air-inflated balloon that can expand and contract depending on how much gas is inside. When the swim bladder expand, it will increase in volume, therefore displace more water. This increases the fish buoyancy and it will float upward because the buoyant force is greater than the weight of the fish.
Oh, okay, lain. So, ni awak relatekan dengan topik apa ni? Ni awak relatekan dengan topik apa?
Buoyant force.
Oh, buoyant force. Okay. Okay, jadi kan kalau tengok ni kat sini saya tengok berapa markah ni. Ada tak cakap tentang pressure body decreases? Tak ada
Tak ada.
Okay, and then ada tak cakap tentang depth decreases? Sebab story dia, awak dengar suara saya? Ceritanya dia kata fish tu move up quickly from deep sea. Jadi kalau kita bayangkan, saya tak nak conteng kan. Kalau apa yang saya boleh buat ni? Daripada sini, you all punya ni boleh saya pegang ke apa-apa. Soalan je ni, kalau you tengok kat bawah, explain why tengok ikan tu, explain why the air bladder expands when the fish moves up. Moves up daripada mana? From deep sea. Jadi kan, kalau kita ada gambar ocean, kan? Bawah tu ke atas. Perbezaan apa daripada bawah sekali? Deep sea. Seabed, dia depth, dia high kan? Tapi kalau air tu dekat atas, ikan tu naik atas, depth tu berubah. Depth tu berkurang. Okay. Jadi tengok pada gambar balik kat atas tu. Gambar atas, gambar soalan yang pertama ni. Yes, ni besar kan? Besarkan soalan ni. Bukan besarkan lah, no. I mean, you pinch you punya ni. Zoom, zoom. Lagi. Okay, gambar ni, dia related to the question tadi tu. Apa yang awak nampak pada gambar ni? Oh, so this is volume Awak nak relatekan dengan volume. Jadi kat sini volume tu bertambah disebabkan oleh, okay, ada perubahan dia punya height tu. Nampak? 1, 2, 1, 3. Surface area sama. Jadi volume tu berubah ataupun depth tu. Okay. Jadi kalau tengok pada jawapan you all ni memang lain lah dengan yang tadi. So mana jawapan yang better class? The rest of you.
Yang berkaitan dengan depth.
Yang berkaitan dengan depth. So this is about Boyle's law ke buoyant force?
Boyle's
law.
Boyle's law. Dia lebih kepada pressure. Okay, thank you. So tadi siapa? Adam Daniel Adam Daniel ada lagi soalan?
Diagram 3.3 shows a model of solar oven to be used to fry eggs. Using the appropriate physics concept, explain the use of suitable materials and design to improve the heating process of the oven. Your answer should include the following aspects. One property of the cover, the specific heat capacity of the pan, the color of the pan, the specific heat capacity of the body, and finally ability of the body to tilt. So dia punya markah 10. So first untuk aspek property of the cover, The characteristics that we choose is transparent. Reason is to reduce heat loss and to allow heat to flow to the pan by radiation. Next,
To reduce heat loss.
to reduce heat loss and to allow heat to flow to the pan by radiation.
Boleh terima.
Okay. Specific heat capacity of the pan, low. Reason to allow the pan to heat up quickly. Color of the pan, characteristics dia black. Black color absorbs and radiates heat quickly. Next, specific heat capacity of the body. Characteristics dia high specific heat capacity. Reason, heats up slowly and less heat release to surrounding. Finally, ability of the body to tilt. The characteristics are hard to tilt, large base area and short body. The reason is to lower the center of gravity and food does not fall from the pan. Boleh diterima ke cikgu?
Specific capacity big, high. So kenapa? Easily. Okay, betul. Ability to the body must be able to tilt. Tilt, hard to tilt ke easily tilt? Kumpulan lagi satu. What's your opinion?
Easily tilt.
Okay, beza jawapan.
Beza.
Okay, so kenapa yang kumpulan sana tadi kenapa nak easily tilt?
Allow sunlight directed into the oven in straight line je. Nak allow sunlight.
Nak easily dapat sunlight lah. To face the direction of the sun to get maximum heating. Yang ni hard to tilt so that lower the center of gravity. Hard to tilt ada kaitan ke dengan lower center of gravity? Tak ada kan? Kalau awak boleh tulis ni awak you're talking about tilt. Ni I'm talking about this group yang tengah present ni. Ability of tilt, so you focus lah hard to tilt ataupun easy to tilt. So better answer ataupun the answer is easily to tilt. Kenapa?
Cikgu.
Yep.
Satu lagi easily to tilt tu sebab nak even the cooking process.
Boleh, betul. So kenapa nak even cooking process? Back to the answer to face the direction of the sun lah. Okay, so yang ni salah group ni Sharifah. Dekat short body semua tu boleh terima. Ini soalan apa? Ini adalah soalan
essay.
Yalah memang essay. I mean this is modification kan? Soalan apa kita panggil soalan suggestion ataupun modification. Jadi awak nak buat lebih pun boleh. Lepas tu kat sini kata short body, large base area. Boleh diterima lah. Kenapa? Cuma kat sini mungkin extra lah. Tapi kat sini soalan ni dia dah bagi exactly 5. Jadi exactly 5 tu awak kena cakap apa yang dia bagi je. 1, 2, 3, 4, 5. Okay, tapi kalau dia tak bagi 5 ni awak boleh tambah short body, large base area. Itu semua boleh ditambah kalau tak diberi.
Cikgu?
Yep.
Jadi kiranya kita orang hilang markah dekat the whole untuk ability of the body to tilt ke? Oh, okay.
Yep. So awak dapatlah 8 markah saja. Okay. Okay, thank you. Ada lagi?
Okay dah, cikgu.
Alright. So kita continue with the next question. Page berapa ni yang bukan? Page 24. Okay. Please proceed. Besarkan sikit Okay dah. Alright.
Assalamualaikum warahmatullahi wabarakatuh. Okay, we're from XLR3. Kita orang akan explain question page 24 until 25. Okay. First question, as many people strive to live healthier lifestyle and eat a healthier diet, many new diets call for steamed vegetable. The easiest method for cooking food is to use a food steamer. What is the meaning of specific latent heat of vaporization? The quality of heat that is absorbed during boiling or released during condensation.
Okay. Macam mana? The quantity of heat tu betul that is absorbed during boiling or released during condensation. Okay, betul. Tetapi kena tambah lagi tu. Belum cukup untuk dapat satu markah. Cuma awak boleh cakap satu je lah kan. Sebab dia kata ni vaporization. Okay. So awak pilih salah satu. And then nak tambah apa ni? Kelas. Ataupun group members ke, kelas ke. Ya?
Substance.
Apa yang paling penting sekali tentang latent ni? Substance tu kenapa?
Untuk change physical state lah cikgu.
Nah, kena sebut. Kena sebut. Okay. Change in change in state. Sebenarnya dah ada bila boiling orang tahulah ada change of state kan. Okay. To change of state. Lepas tu ni spesifik kan? Soalan tanya spesifik kan?
Spesifik.
Jadi kena tambah apa?
1 kg.
Of 1 kg object atau 1 kg substance. Alright, tambahkan tu ya. 1 kg substance. Without change of temperature. Okay. Ni semua kena sebut. Panjang. Jadi beza dia dengan specific capacity tadi, itulah dia. Capacity dia 1 degree Celsius increase ataupun decrease temperature. Tapi kalau latent heat, awak kena sebut dia 1 kg kalau dia sangat specific, and then awak kena sebut ada state of change, ada change of state. And then sebab kat sini dia sebut pula vaporization, awak kena spesifikkan lagi apa change of state dia. Sama ada awak cakap boiling ataupun condensation, ataupun awak cakap state from apa? Liquid to vapor or vapor to liquid. Mana-mana lah antara awak cakap change of state tu ataupun boiling tu. Alright. Hati-hati ya yang ni semua orang. Okay, next question.
Second question. Explain how food is cooked by the food steamer in diagram 11.1 in terms of the transfer of heat. First, water has large specific latent heat of vaporization. The lower level that contains water absorbs latent heat to transfer the heat to become steam. And then when steam condenses on the food, latent heat is released onto the food, and lastly enables food to be cooked at faster rate.
Okay. So dapat markah kat mana ni? Heat from the heater transfer to the water. Ada tak cakap mana-mana cakap tentang transfers of heat?
Second one.
The lower level that contains water absorbs latent heat to transfer the heat to become steam. Okay, 1 mark. Water changes to steam. It will become water become steam pun kat situ juga. Dapat markah dekat ayat yang sama, 2 tu. And then steam condenses on food. Ada tak cakap tentang condensation?
The third one.
Okay, when steam condenses on the food. Okay, good. And steam transfer high latent heat to food. Large specific latent heat or vibration. Ada tak cakap steam transfer high latent heat to food? Okay, awak ada cakap tentang high latent heat kan? Ada tak? Tengok atas sikit. 1, 2, 3, 4. Poin atas. Poin pertama tadi. Water has large speculative evaporation. Okay, so instead of water, you may want to talk about steam. Sebab sekarang ni kita tengah cakap tentang steaming process. Jadi you must mention about steam, and steam now transfers high latent heat to food. Okay, so boleh dapat 3 lah, 3 ataupun 4 markah, depends on pemeriksa. Okay, right, good. So semua orang boleh tambah dia check masing-masing. Yang lain buat tak ni? I hope everyone do it Walaupun bukan kelas awak yang present, semua orang kena buat lah. Sekarang masa untuk mark. Okay, continue.
B1 Sharon poured 0.5 kg of water at room temperature in the lower compartment of the steamer. Find the amount of energy needed to raise the temperature of the water to 100 degrees Celsius. So use the formula Q equals to mc theta and get 1.6 times 10 power of negative 5 joule. Okay.
Sekejap. Betul tak? 3, 4, 5, 5. Yes, betul. Cuma jangan berbundarkan lah. Janganlah bundarkan cepat sangat. Awak buat je 1.5 apa?
5.8.
5.8 ataupun sebab saya pernah ceritakan tentang, saya cerita dekat siapa 0.5 ke 0.4. Jangan round too much. Sebab I cannot recall saya cakap dengan siapa, tapi this is about SPM lah. As you know, saya cakap dekat sekolah lain. Sebab saya bila menanda last year saya macam agak terkejut lah. Bila student bagi jawapan akhir dalam standard form, student kan bagi macam awak ni kan, awak buat 1.6 kan. Jadi tahun lepas tak diterima tau. Banyaklah kita orang question kepada ketua pemeriksa. I shouldn't talk about this. Tapi saya nak bagi tahu lah. Kita orang macam argue kenapa tak terima 1.6. Tapi dikatakan kalau dapat, cuba you tengok 157,500. Katalah duit awak ada dekat bank, awak ada 157,500. Ni duit awak dekat dalam bank. Kalau saya ambil 500 without you knowing, are you okay with it? 500 is amount of money kan? So are you okay with 500 hilang daripada you tu?
No.
Mestilah awak macam 500 still my money, walaupun 500 je, tapi still my money kan. Jadi dia ada value dekat situ ataupun dia significant dekat situ. So you must have you must write complete lah. Jadi awak kena sebut, awak tak boleh round ni. Awak kena tulis 1.575 times 10 to the power of negative 5. Negative 5? Is it negative 5 kakak? Aduh, ini masalah ni. Bukan negatif. Negatif ke positif? Five eight tu pun tukar. Bukan 58 575. So nampak, faham tak point saya tadi? Ni group Spiderman ke apa ni? Semua jadi Spiderman ni. Ni. Faham ya kelas? What I'm trying to say tadi? Jangan round off kan. Kalau awak boleh round off banyak tu kalau dia 0.0000001.5. Itu tak apalah. Awak buatlah. Tapi kat sini, okay. So nak guna standard form pun betul-betul. Tadi awak buat jawapan 1.6 times 10 to the power negative 5 tu salah. Negatif tu maksudnya. Buat kecil tu. Okay, continue.
So B2, the fluid in the steamer needs 4.5 times 10 power of 5 joule of heat to be steamed. Calculate the mass of water that was converted to steam during the steaming of the fluid. So use the formula L equals to Q over M, M equals to Q over L, and get 19.57 times 10 power of negative 2 kilogram.
Okay, ni betul. Good. Okay.
Dengar ke?
Dengar.
Kurang.
Okay, question number 3. State one assumption that you have made in 11B1. It takes 1.6 times 10 1. It takes 1.575 times 10 power of 5 for the water to heat up until 100 Celsius to steam the food. Jadi cikgu, kita orang tak faham sangat lah cikgu nak buat assumption for this questions.
Okay, ni satu markah je. Dia kata one assumption you made in 11B1. So 11B1 tadi soalan pasal apa?
Soalan pasal amount of energy needed.
Okay, how do you get that formula? Macam mana awak gunakan formula Q equals to MC data tu?
Dia
What did you assume? Where did you get all the heat from?
specific heat punya formula cikgu.
Memanglah. Okay. Semua orang semualah. Mana-mana semua orang baca soalan tu. So, find the amount of energy. So, that's the question kan? So, mana datang energy ni? From where?
Steamer.
From steamer. Steamer tu daripada mana? Siapa yang panaskan steamer?
Elektrik.
Elektrik tu daripada mana? Semua tu lah. So kat situ ada transfer of energy. Jadi you get the heat tu from the steamer ataupun from the boiler ke whatever tu. Jadi apa yang kita assume? Class. What did we assume? When there is change of temperature, when there is transfer of heat, we are assuming that
No heat loss.
no heat loss to the surroundings. Okay? Faham tak? Maksudnya semua yang daripada kabel-kabel elektrik tu transfer, absorb effectively by the boiler ke ataupun tu. And then boiler tu panaskan betul-betul air tu. Air tu jadi steam. Panaskan nasi, lauk ataupun makanan. Macam tu lah. Nampak tak? So kat sini konsep ni kita dah kena faham betul-betul. Oh, kenapa ni semua berlaku. Okay? So next question.
Diagram 11.2 shows a cooler bag which can be used to keep food cool or warm. Table shows the characteristic of 4 different cooler bags. You are required to determine the most suitable design of cooler bag that can keep the food cool or warm for a longer period and that is easy to carry from place to place. To study the specification of all 4 designs from the following aspects: thermal conductivity of the bag, specific heat capacity of the bag, density of the bag, and material for the inner lining. Explain the suitability of the aspects, then determine the most suitable design of cooler bag. Okay. So, aspect number 1, thermal conductivity of the bag. Characteristic is low because it do not let heat pass through them easily. And the second aspect, specific heat capacity of the bag, should be high so that it takes less time to absorb heat. And the density of the bag should be low because higher melting point so it can withstand high temperature. And the material for the inner lining should be thermally insulating materials such as aluminium foil so that it can help maintain the temperature of its content. I salah cikgu.
Okay. So you boleh terus cakap aluminium foil. Okay. And then apa karakteristik aluminium foil tu?
Thermally insulated cikgu.
Insulated ke? aluminium foil metallic kan? Metal kan? Kalau metal dia insulator. So awak boleh cakap dia metal, awak boleh cakap dia, kalau metal warna apa dia? What's the colour of aluminium foil?
Shiny.
Dia shiny kan? Shiny and dia shiny. So with the shining tu, what is the characteristic? It reflects heat back to the food. So that's why kita gunakan dia. Okay, kita nak dia punya reflection tu. Right. So your conclusion, you choose P. Correct? Kenapa P? And then you have to repeat everything again. Okay, sekarang tadi low thermal conductivity. Okay, correct. So kenapa do not let heat pass through the easily? Okay, bolehlah tu. Itu maksud lain dia adalah heat insulator ataupun to prevent heat loss. Okay, boleh tanda masing-masing punya. And then specific heat capacity of the bag mesti high, betul. Because takes less time to absorb heat. Okay, okay, good. Dah 4 markah dah. And low density, of course. Kenapa nak low density? Apa kaitan low density dengan higher melting? Do you know what is so that it can withstand high temperature? Apa reason tak kena lah low tu? Faham tak low density tu apa? Low density tu maksud dia apa?
Tak
Low density maksudnya apa? Apa tak dengar? Aduh. Low density maksudnya apa? Dia punya mass tu rendah lah kan. Jadi bila mass rendah, dia ringan. Jadinya low density, so it is light. Selalu macam tu. Awak jangan pandai, awak pangkah je. Nanti awak ingat sikit. So macam ingat kalau low je, awak ingat low density je, light. Low density je, light. Tak ada reason lain dah selain daripada tu. Kalau dia dah bagi tahu dalam soalan sebab dia nak light, awak cakaplah low density, dia portable lah macam tu. Okay, so yang lain semua okay. So kalau ini dalam exam, awak dapatlah 9 markah. Okay, next. Okay, kita ada perempuan lagi yang belum present. Perempuan pun belum. Dah 9.35, silakan. Kenapa ada banyak Spiderman ni? Okay.
Assalamualaikum. We are from group 6, from class 5 BTech. We present answer for question 20 from page 26 to 28.
Okay, number 2, diagram below shows a metal block M of mass per 100 gram heated in boiling water of temperature 100 degrees Celsius for a long time. The metal block M is then quickly transferred into 200 gram of water at 30 degrees Celsius in a polystyrene cup. The water is stirred until thermal equilibrium is received. A1. What is the meaning of thermal equilibrium? The condition where there is no heat transfer between two objects in thermal contact.
Okay.
Explain in terms of thermal equilibrium how a temperature which is placed into the boiling water reaches a temperature of 100 Celsius. When the thermometer is placed in the boiling water, net heat transfer will occur between the water and the thermometer. The mercury inside the thermometer expands as it gains heat energy from the boiling water. The thermometer will stop expanding when both water and thermometer reach thermal equilibrium. As water and the mercury of thermometer reach thermal equilibrium, they have the same temperature, which is 100 Celsius.
Okay, kejap So soalan dia suruh explain. Jadi bila explain in terms of thermal equilibrium. So apa yang jawapan apa ni? Tak nampak lah. Explain in terms of thermal equilibrium. When the thermometer is placed in the boiling water, net heat transfer will occur. Okey. So sekarang ni awak bayangkan situasi dia, kita ada termometer. Termometer tu dekat luar. Lepas tu at the same time we have water that is boiling. Jadi now kita ambil termometer tu, kita put into the boiling water. Jadi apa yang what is the condition of the boiling water compared to the thermometer? So you kena cakap lah, temperature of boiling water is, ada tak sebut?
Temperature tu kita orang stick kat point keempat je.
As water or the micrometer reach to microgram, they have the same temperature. Okay, itu dah bagi tahu dia ada reach. Ni before tu. Jadi kan soalan ni dia lebih kepada cakap how. Bila bulatkannya, kalau you print paper ni you bulatkan. Kalau you ada screen you boleh conteng, you conteng screen you. Bila sebut how, it's a process. Bila it's a process, you must start from the beginning. Okay, so tadi beginning tadi saya cerita tadilah, kita ada thermometer tu kat luar tu. Jadi barang yang kita nak we want to measure the temperature somewhere else. Jadi at the beginning, the two objects ataupun the two substances have different temperatures. So awak kena bagi tahu dulu, the temperature of boiling water is higher than the temperature of the thermometer. So itu the first mark. And then apa sambung proses tu? And then heat flows from boiling water to the thermometer. Jadi kan kalau saya lukis ni, awak boleh bayang tak apa saya lukis dulu? So awak bayangkanlah saya ambil thermometer, saya letakkan. Bila saya letak je thermometer into the water, apa yang berlaku? Heat from where? Of course heat from the boiling water. Jadi nampak ada tak perkataan boiling heat water? Okey, ada Ada tak sebab cakap macam mana-mana yang heat flows from boiling water to thermometer?
Ada cakap dia gain energy from boiling water lah dekat point ni.
Boleh? Okay, good. So dapat satu markah dekat sini. Tapi kan markah ni sama dengan markah. Okay, markah yang boleh tak saya nak request control? Kalau saya boleh dapat control Okay, so apa yang saya dapat control? Tak dapat apa pun. Okay, so kalau markah tadi ni, markah ni, heat energy from the boiling water tu, dia markah dia sama dengan markah, bukanlah sama, dia bersambung. Achieve thermal equilibrium. Where did you write about thermal equilibrium? Ni, reach thermal equilibrium. So markah yang poin ketiga dengan poin keempat tu, satu markah. Okay, next, the temperature of the boiling water is the same. Ini markah yang lain pula. Ini markah yang ketiga. Okay, next. No net heat flows at 100 degrees Celsius. Did you see anything about no net heat flow?
Tak ada, tapi kita orang ada cakap pasal reach thermal equilibrium je.
Dekat sini kan?
Jadi
soalan ni, ingat saya ada share. Saya tak tahu saya share kat mana. Oh, itulah. Awak ni dah dapat teknik ke? Saya kan, nanti saya bagi link-link kepada teknik-teknik menjawab yang saya bagi dekat MSM lain. Jadi bila sebut tentang explanation, okay, awak tulislah. Saya rasa saya ada bagi tahu juga dekat you all ni. Tapi kan bila sebut explanation, you boleh cakap apa? You boleh cakap tentang definition of. Ada tak pasal definition? Kalau untuk soalan ni ada tak definition? Yes, ada. Definition apa? Definition of thermal equilibrium. So that's the first thing. Ni tips lah. Tips untuk menjawab SPM ni. Jadi kedua apa? Ada tak principle ke? Ada tak formula ke? Ada tak law ke? Macam tu lah. Kalau ada, tulis exactly apa statement of the law. Tulis exactly what is the statement of the principle. Okay, for this question, you have to write semua sekali definition of thermal equilibrium. So, kalau awak tulis definition of thermal equilibrium, automatik awak dapat markah 1 dengan 2. Okay? Markah 1 dan 2 pula. Markah 4 dan markah 3. Okay. Jadi sebenarnya kat sini, macam tak ada lah sebenarnya cakap tentang no net heat flow. Awak cakap thermal equilibrium. Jadi macam bila kita menanda kan, macam cikgu kena assume. Awak cakap cikgu assume thermal equilibrium tu cikgu faham lah, no net heat flow tau. Tak boleh. Kita kena tulis. Alright. Okay, continue.
Okay, next for soalan B1. Calculate the final temperature of the water in polystyrene cup. So, kita orang guna formula Q equals to MC theta. So, since dia punya final temperature sama, that means dia orang reach thermal equilibrium lah. So, kita boleh buat Q equals to Q, which is MC theta equals to MC theta of block metal M to the water in polystyrene cup. So, ikut macam ni. So, nanti just rearrange and then dapat dia punya final temperature untuk both metal block M dengan water in polystyrene cup.
Okay. Very good. Okay, so nampak tak kat sini? Soalan dia lebih kurang sama je. Mesti dia tanya lepas tu. What assumption? So, what's the assumption? Dah habis cakap ke tadi pasal pengiraan tu dah kan?
Pengiraan dah habis lah.
Okay.
So B2, state one assumption that you made in B1. So no energy loss when transferring metal block from the beaker to the polystyrene cup.
Okay, good. So now semua orang dah tahu lah So kalau taja topik ni dia cakap je assumption, memang kita assume no heat loss. Jadi kalau ada heat loss tak boleh kira ni kan, nak kena cari pula heat loss tu berapa. Jadi kita assume saja no heat loss. Okay.
Question C. Explain the suitability of each characteristic of the thermal flask and determine the most suitable thermal flask to be used for the purpose of maintaining the temperature of the hot drink. First, stopper is use solid plastic. The reason is no energy loss to surrounding. Number 2, Swiss wide. Use vacuum. No medium for heat energy transfer. Number 3, the material is glass. High specific heat capacity. Number 4, shiny paint. The reason is to reduce heat loss by radiation. So the most suitable flask is flask W because it has vacuum in space B, glass as material, and is coated by shiny paint.
W macam kontra je dengan jawapan awak. Awak pilih W tapi awak nak hollow ke awak nak solid tadi?
Dia kalau dekat yang flask tu dia tak ada karakteristik yang semua tepat tu. Yang W je yang paling banyak karakteristik yang tepat.
Okay, awak nak vacuum, awak nak glass, lagi awak nak shiny kan? Betul tak? Jadi semua tak ada yang lain-lain tu. So automatic jawapan awak kena tukar lah. Awak nak hollow ke awak nak solid? Faham tak? Jadi jawapan awak sekarang ni saya tak sure lah apa yang awak confirm sangat jawapan je W. Tapi katalah dalam exam kan, awak confirm mesti yang ni sebab karakteristik yang lain tu memang kita nak shiny. Yang shiny lain Z. Z copper, we don't want copper. Kan macam tu. Jadi bila awak pilih copper je awak macam bila awak pilih je glass awak macam dah confirm dah. Betul? And then shiny paint pula awak confirmkan lagi, awak double confirm awak punya pilihan tadi. So awak tengok balik Z, dia lagi guna air. Awak tak nak air, awak nak vacuum. So automatic bila dah ada 3 yang awak setuju, ada satu yang tak setuju, maksudnya mungkin satu tu awak salah faham. Jadi awak pilih juga yang sebenarnya apa dia tulis. Faham tak? Faham tak ni apa saya cakap ni? Jadi sepatutnya bila awak dah pilih W tu, awak pilih juga tukarlah, bukan solid. Jawapannya apa? Jawapannya hollow pasti. Lepas tu awak fikirlah kenapa hollow. So at least kalau lah reason awak tu salah, kan? Kalau reason awak salah, at least jawapan stopper tu dah betul dah hollow. So hilang satu markah je. Kalau macam ni, awak kira macam awak degil kan, awak ketekak nak juga solid plastik tu, dah 2 markah hilang. Okay Okey, jadi kan kalau kat sini kita nak hollow, kenapa kelas? Kau boleh bayang tak hollow plastik ni, stopper kat atas tu? Flask. Pernah ada flask tak? Ada baby tak kat rumah? Dulu-dulu. Ataupun kalau pergi travel dulu-dulu pergi pantai. Dulu-dulu tu macam dah lama je kita hidup. Masa zaman sebelum PKP lah. Kalau pergi pantai ke apa bawa flask. Pernah tengok flask ni?
Pernah cikgu.
Penutup dia macam mana? Solid ke keras? Tebal ke? Dia memang tebal tapi awak buka dia punya lid tu dia ada hollow lah kan? Kenapa? What's the reason class? Di mana group group members group member dia mesti jawapan sama je. Ahli kelas BTEC, RBT yang lain buat tak? Kenapa nak hollow?
To reduce heat loss by conduction ke cik?
High conduction, apa macam ni?
To reduce heat loss by conduction.
Betul. Very good. Betul. Okay. Ataupun simple cakap, kenapa ada jawapan lain untuk macam tadi dia ni dah cakap. Kenapa nak, macam mana dia boleh reduce heat loss by conduction? Sebab dia ada hollow tu, dia trap air. Air ni satu insulator kan. Okay. Alright, so itu jawapan-jawapan dia. Okay, yang lain tu semua betul lah. Nak vacuum. Kenapa tadi reason awak nak vacuum? No medium for heat energy transfer. Betul. Lagi dia nak glass. Of course betul. Bad conductor juga kan. Ataupun awak kata heat. Okay, boleh. Glass sebenarnya tak adalah high specific capacity sangat Cuba tengok dalam textbook. Glass punya specific capacity berbanding dengan yang lain. Glass tak tinggi sangat. Oh, dia ada bagi awak refer kat situ. Boleh lah. Dia high specific capacity. Okay, next lagi. Awak pilih shiny sebab reduce heat loss juga. Banyak ni pasal heat loss. Jadi apa lain selain daripada heat loss, awak boleh cakap apa ni? Reflect tadi kan. Reflect tadi. Jadi bila awak nak nampak dekat sini dia buat energy loss no medium. Awak boleh repeat heat loss tu dua kali je lah. Lepas tu awak cari reason lain. So kat sini memang ada reason lain which is reflection. Okay.